Next we have William Burt, whose thesis is the use of radium isotopes to investigate boundary exchanges in coastal ocean systems.
Remember the last time you went to Peggy's Cove? You walked around on the rocks, but you didn't take in the beautiful scenery. Instead, you walked around snapping some selfies. Well, I hate to tell you this, but the best part of those selfies is not you. And it's not the lighthouse. It's the coastal ocean system in the background. And that's because coastal ocean systems provide us with food, with recreation, with transportation, and with energy. But over the past few decades, atmospheric carbon dioxide levels have increased steadily, and some of that CO2 makes its way into our surface oceans. Now, CO2 reacts with water to make a weak acid, so this continual uptake is causing our oceans to become more acidic. Now, some organisms, like this clam or that critter, can't grow their shells properly under more acidic conditions. And that's a big problem, because clams are delicious, and that organism happens to be an important food source for a lot of economically important fish species. So, ocean acidification is causing a fundamental threat to our ocean ecosystems. Now, my thesis looks at this problem specifically. In the open ocean, this problem is relatively well understood. But in coastal systems, this is not the case. In the European North Sea, on the other side of the Atlantic, acidification is happening 10 times faster than what we see in the open ocean. On the other side of the Atlantic, on the Scotian Shelf, which is that background in your selfie, we are seeing CO2 making its way back into the atmosphere. So what's going on? Why are these coastal systems so different? How do we explain this variability? Well, that's where my thesis comes in. I think that the atmosphere and the ocean is one boundary, but we have to look at the other boundaries of coastal systems. That is the boundaries with land, with the seafloor, and with the open ocean. So with that in mind, I go out on ships and I collect water samples and I measure the amount of CO2 in those water samples. But I also measure the amount of radium in the water. And I measure radium because it has unique properties in that it enters the ocean, the coastal ocean, from these two boundaries. So by measuring radium along with CO2, we're able to quantify the amount of carbon dioxide that comes in at these boundaries. And by doing that, we gain a better understanding of the CO2 cycling in the system. We get a better understanding of acidification in general. And in doing that, we understand the changing health of the background in your selfies. Thank you.